projects. In this video, we are going to explain about the project, which is Can Online Consumer Reviews Signal Restaurant Closure? A deep learning based time series analysis. Introduction of the project. The project centers on the critical stage of business closure in the business life cycle, recognizing the significant threat faced by various industries. Drawing from the empirical data, it highlights alarming closure rates such as 17% of restaurants within the first year, emphasizing the need for proactive measures to address and predict closures. Despite the potential for positive learning experiences in the closure process, there is prevalent association between business closure and the failure, leading to discouragement among business owners. The aftermath of closure entails serious psychological, social, and financial repercussions, underscoring the importance of predicting closures for timely preventive actions and informed decision making. The existing study reveals a gap in the research concerning the prediction of business closure, often attributed to small sized and self reported data. Existing studies predominantly draw factors from managerial and economic dimensions, neglecting consumer generated information. The project aims to bridge the gap by proposing a decision support tool focused on online reviews as predictive indicator. Recognizing the emerging trend of leveraging online reviews for understanding business performance, the project proposes a novel approach. It suggests the use of online reviews as input for a customized convolutional neural network model. This innovative method aims to predict business closure by capturing nuanced information within the multivariate time series data for consumer opinions. The project distinguishes by adopting a holistic approach, moving beyond business features to explore diverse factors such as economic conditions in predicting closures. It emphasizes the development of an analytical pipeline to identify and extract information signals from online reviews, acknowledging the need for a comprehensive understanding that goes beyond individual store attributes and incorporates dimensions like local competition and varying time lags in consumer sentiments. Objective of the project. The project aims to redirect the identification of factors influencing business closure from traditional managerial and economic dimensions to the consumer dimension. This shift underscores the significance of understanding consumer sentiments, particularly in industries prone to high attrition rates like restaurants. The overarching objective is to integrate advanced technologies, specifically deep learning and time series analysis techniques. This integration seeks to enhance the accuracy and reliability of business closure predictions by accounting for a dynamic nature of consumer reviews over time. The project aims to analyze the classes to be predicted in the context of business closure using online consumer reviews. This involves categorizing reviews into positive, negative, and neutral sentiments, providing a nuanced understanding of consumer perspectives contributing to the prediction model. The overarching objective is to employ a diverse set of machine learning and deep learning algorithms for building predictive models. And the algorithms such as logistic regression, MLP, SGD classifier, MNB classifier, naive Bayes classifier, rich classifier, linear SVC, LSTM, BiGRU, CNN, and CNN with LSTM are chosen to capture various aspects of online reviews. The project's goal is to evaluate the performance of predictive models using comprehensive metrics such as accuracy, precision, and recall. This approach provides a thorough assessment of the model's effectiveness in predicting business closures based on online consumer reviews. Accuracy gauges overall correctness, precision assesses the relevance of the positive predictions, and recall measures the model's ability to capture all relevant instances of the business closure. To implement the project, we need software and hardware requirements. And the software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. This step involves importing necessary Python packages and libraries that are required for data manipulation, visualization, machine learning, and web development. We have imported Pandas and NumPy for data manipulation, Matplotlib and Seaborn for visualization, Scikit-learn for machine learning, TensorFlow and Keras for deep learning, Flask and SQLite for web development. The next step is exploring the dataset. The dataset, which is Yelp, is explored to understand its structure, features, and the content. Exploratory data analysis involves examining the data types, distribution of values, and the basic statistical summaries to gain insights. Coming to visualization, visualization is employed to provide a sample outcome of the dataset. This includes plots, charts, and other graphs to showcase specific aspects of the data, giving stakeholders an initial understanding of its characteristics. The next step is data processing. Data processing involves several substeps to clean and prepare the data for analysis and model training. Here, we remove URLs and other unwanted characters to ensure text clarity. We remove punctuations to simplify text data, eliminate stop words like which are common words like the and is to focus on meaningful content. We normalize the data, which potentially involves converting all text to lowercase for consistency. We lematize, which reduces words to their base or root form, ensuring the uniformity. The next step is feature selection. Feature selection involves choosing relevant features that contribute the most to the predictive power of the model. This step aims to enhance model efficiency by using only essential information. The next step is splitting the data into train and test. The data set is divided into training set and a testing set. The training set is used to train each model while the testing set is used to evaluate the model's performance on unseen data, ensuring its generalizability. Building the model. This step involves defining the architecture of the deep learning models and parameters of machine learning models. Training the model. The model is trained using the labeled training data. During this phase, the model learns the parameters and relationships between input features and output labels. Flask framework with SQLite for sign up and sign in. Flask, a web development framework for Python, is integrated with an SQLite database to implement user sign up and sign in functionalities. This sets the groundwork for user interaction with the application. User gives input. User provide input like in the form of text data through the application's front end. Pre-processing user input for prediction. The input provided by the user is pre-processed using the same steps as the data processing phase to ensure consistency and compatibility with the trained model. The next step is trained model is used for prediction. The pre-processed user input is then fed into the trained machine learning model which predicts the desired outcome based on the patterns it has learned during training. The last step, which is final outcome, is displayed through frontend. The final prediction outcome is displayed on the application's frontend, allowing users to see the model's assessment based on their input. Now we will know what are the algorithms used in the project. The first algorithm is logistic regression. It is a binary classification algorithm that predicts the probability of an instance belonging to a particular class. It uses the logistic function to model the relationship between the independent variables and the probability of a particular outcome. Logistic regression is used for binary classification tasks. In this project, it is employed to predict whether a given input, such as a user review, corresponds to be a positive, negative, or neutral sentiment regarding business closure. The next algorithm is multi-layer perceptron. It is a type of artificial neural network characterized by multiple layers of interconnected nodes which are neurons. It consists of an input layer, one or more hidden layers, and an output layer. MLP is known for its capability to learn complex relationships in the data. MLP is employed for tasks where nonlinear relationships need to be captured. In this context, it is used for its ability to understand intricate patterns in user reviews and predict business closure sentiments. The next algorithm is SGD classifier, which is stochastic gradient descent. It is a linear classifier that utilizes stochastic gradient descent as an optimization technique. It iteratively updates the model's parameters to minimize a specified loss function. SGD classifier is suitable for large data sets and it is often used in text classification tasks. It is employed to efficiently train a model on large volume of user reviews for predicting business closure sentiments. The next algorithm is MNB classifier, which is multinomial naive Bayes. It is a probabilistic classifier based on Bayes' theorem. It is suitable for classification tasks with discrete features often used in text classification. MNB is well suited for text data and it is applied to predict sentiments in user reviews. It assumes that features are conditionally independent given the class label, making it efficient for large scale text classification tasks. The next algorithm is naive Bayes classifier. It is a family of probabilistic classifiers based on Bayes' theorem, with the strong assumption of independence between features. Naive Bayes is known for its simplicity and efficiency in text classification tasks. It is employed to predict sentiments in user reviews, assuming independence between words in the reviews. Rich classifier. It is a linear classifier that uses rich regression as a regularization technique to prevent overfitting. It is commonly used for binary and multi-class classification problems. Rich classifier is applied when there is a concern about overfitting and regularization is needed. It is enhanced. It enhances the model's generalization ability when predicting business closure sentiments. The next algorithm is linear SVC, which is support vector machine. Linear SVC is a linear classification algorithm that uses support vector machine for binary and multi-class classification. It aims to find a hyperplane that best separates the classes in the feature space. Linear SVC is chosen for its effectiveness in separating classes in high dimensional spaces, making it suitable for tasks, text classification tasks like predicting sentiments in user reviews. Coming to LSTM, which is long short term memory, it is a type of recurrent neural network designed to address the vanishing gradient problem in traditional RNNs. It is effective in capturing long term dependencies in the sequential data. It is suitable for processing sequences of the data, making it excellent choice for analyzing the sequential nature of user reviews. It captures temporal patterns and dependencies in sentiments related to business closure. Coming to BiGRU, which is bidirectional gated recurrent unit. It is another type of recurrent neural network that is bidirectional, meaning it processes the input sequence in both forward and backward directions. It is effective for capturing context from both past and future inputs. It is applied to enhance the understanding of contextual information in user reviews. It captures dependencies and nuances in sentiment that result from bidirectional processing. Coming to CNN, which is convolutional neural network, it is a deep learning algorithm that commonly used for image recognition, but it is also effective for processing grid-like data such as sequences. It uses convolutional layers to detect patterns in the input. CNN is used to capture hierarchical features in the sequential data for user reviews. It identifies important patterns and relationships in the text data, contributing to accurate predictions of business closure sentiments. The next algorithm is CNN with LSTM. Combining CNN with LSTM involves leveraging both convolutional layers for feature extraction and LSTM layers for capturing sequential dependencies. This hybrid approach aims to benefit from the strengths of both architectures. It applies harness the strengths of both CNN and LSTM, offering a comprehensive understanding of spatial and sequential patterns in user reviews related to business closure. The last algorithm is CNN with bi-LSTM, which is bidirectional LSTM. Similar to previous combinations, this model involves integrating CNN with bidirectional LSTM. It combines the ability of the CNN to capture spatial patterns and the bidirectional processing capability of bi-LSTM to capture contextual dependencies. It is chosen to optimize the model's ability to understand both spatial and contextual features in user reviews, providing a well rounded approach for predicting business closure sentiments. As an extension, we applied an ensemble method and hybrid methods combining the predictions of multiple individual models to produce a more robust and accurate final prediction. Also, as an extension, we built the front end using Flask framework for user testing with the user authentication. We have used accuracy, precision, recall, and FN score, which are the performance metrics to evaluate the project. So here we have performance comparison graphs of the project. This is accuracy comparison graph. Here, x-axis represents accuracy score for each algorithm and y-axis represents algorithm names. Similarly, we will have for other graphs also. Accuracy measures the overall correctness of the model by calculating the ratio of correctly predicted instances to the total instances. This is precision comparison graph. It evaluates the accuracy of positive predictions made by the model. It is the ratio of correctly predicted positive instances to the total instances predicted as positive. This is recall comparison graph. Recall is also known as sensitivity or true positive rate. It measures the ability of the model to capture all positive instances. It is the ratio of correctly predicted positive instances to the total actual positive instances. This is FN score comparison graph. It is the harmonic mean of precision and recall. It provides a balance between precision and recall, and it is particularly useful when there is an imbalance in the class distribution. The algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we need to open the code folder which contains source code. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file. This file contains the algorithm information and that will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of codes, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the sign up file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. By this, current directory will change to the code folder's path. Here we need to type the command python space app.py and then click on enter. By this, it will compile app.py file and it will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and port, unless configured differently. This is the local host, and this 5000 is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. Now we need to open the Google Chrome. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a sign up link. We need to click on that. Here we need to enter all the registration details. If we are registering newly, I have already registered and I have an account in it, so we'll directly sign in. For that, click on sign in. Here we need to provide our credentials to sign in. So I'm giving my username and the password. Now we need to click on login. We have logged in successfully and we are redirected to prediction page. Here we can see a text box wherein we need to give input message in it. Based on the given input message, we will get the prediction whether the sentiment is positive, negative or neutral. So here we will give the message. Click on predict. Here we got the prediction as the tweet type is neutral, which means this message belongs to the neutral sentiment. And the topic for the paragraph is most dependent upon these words. Now we will try giving the other message. Click on home. I have given the message. Now click on predict. Here we got the prediction as the tweet type is positive, which means this particular input message which we have given, it belongs to the positive sentiment and the topic for the paragraph is most dependent upon these words. Now we will give the other message. Click on home. I entered the message. Click on predict. Here we got the prediction as the tweet type is negative, which means the input message belongs to the negative sentiment and the topic for the paragraph is most dependent upon these words. Click on sign out. In this way, if we enter the message to the system, then the system will predict whether the message belongs to positive sentiment, negative, or neutral sentiment. Conclusion of the project. Through the utilization of a diverse set of machine learning and deep learning algorithms, the project achieves heightened predictive accuracy in forecasting business closures. The incorporation of advanced techniques such as LSTM, BIGRU, and CNN enables a nuanced understanding of the textual patterns and temporal dependencies in online reviews. Shifting focus from the traditional managerial and economic dimensions, the project emphasizes the significance of understanding consumer sentiments. By leveraging online reviews, the analysis provides valuable insights into customer experiences, contributing to a more holistic and informed approach to business closure prediction. The evaluation of predictive models employs a range of comprehensive metrics, including accuracy, precision, and recall. This thorough assessment ensures a well rounded understanding of the model's effectiveness, considering both overall correctness and its ability to capture relevant instances of the business closure sentiments. The project demonstrates innovation by integrating a variety of deep algorithms, including traditional models like logistic regression and naive Bayes, as well as deep learning architectures like CNN with LSTM and CNN with BiLSTM. This diverse approach allows for a comprehensive exploration of different aspects in text data, capturing intricate patterns for accurate predictions. The integration of the Flask framework with SQLite for sign up and sign in enhances project's practical application. Users can interact with the trained model by providing input through the front end, enabling real world engagement and feedback. This seamless integration connects the predictive analytics with user interaction for more practical decision making support.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.